Hi everyone. Today let's learn about this find the duplicate subtree question. We are giving a root binary tree and return all the duplicate subtrees. Duplicate is like the same. Subtree. Let's define a subtree. Subtree actually is from any of the node. It can be from root. It can be from any of the nodes, and then goes to the left. Goes to the left. For example, this is a subtree, and this is also a subtree, and this is also a subtree. So each of them can be a subtree, and also only this left is all a subtree, because this left can be have the left and it can be have the right. Even it is known, this is a subtree. What is subtree for here? And we will return the root node of any nodes of them. If there is a subtree, it will be returned. It will be returned. Returned the root node. Yeah. Let's remove those and go through the code. So let's think about this question. So as I think for this one, we will start from the left, right? Because from the left, we already know for the 4, if the left are same, then we will track back to the parent and track back to this root is root. If they're same, then we said 2, 4, then it subtree come from this one, right? If it's not same like this, 4 and 3 and 4 and 2, this is not same. So then it is not the same root tree, but it's still a same. It is still a subtree for the 4, 3, right? So if like that, then I think we can directly from root directly go to the left. After we get left, then we can get each, because we need to know the duplicate, right? Duplicate, then we need to do what? We need count the subtree. Count the subtree and count subtrees. We will be use the map, right? We will use map to the node and the subtree and the count number, right? For the map ones, actually, we have multiple ways to resolve. One is use the what counter. One is use the one of the function default dict, right? Because here we just need a one value. Count is enough, right? For this question, we will use this one to store it, store the tree, store the subtree there. Yeah. Let's directly go to the code. Let's go through it. The beginning of this is defining, then we don't need to spend so many times. And the key part is the function part, how we define the function. As we said that we wanna store each of subtree, right? For the 4, we wanna store 4, right? For the 2 start, we wanna store 2 and 4, right? For 1 start, we wanna store 1, 2, 4. This is if one subtree. For one start, actually, we want to also store the 1, 3, 4, or 1, 3, 2, 4. This is all the subtree, right? And we count how many of them is duplicate. Yeah. So we will use we will use DFS recursive. First we directly go to the nodes left, as we said. We will directly because all of the function we will start from root, right? So for example, we come from here, we goes to root. For example, root node, first node is 1. We use node to the left, right? Then node to the left, node is 1, and we goes to node to the left. 1's left is 2, right? But here actually we didn't run this right. We will directly go 1's left, and 2's left, and 4's left, right? Goes after we go to node 4, we can see node, then if here is 4, we will see it's not node. It is node, right? Node the left, 4's left is not, right? it will goes back to here. It's none. Then we will get this, get this, and then it will go to node right, node right, node left, right, node left already this, but and from node is 4's left, we run this one, right, and then node the left is none, none's right is also none, right, this is none. Then we will be put a value and left and right in there. If node their left is none, then it will be add this one first. And for here, we will back to 4, right? 4's left is none. We return for this. 4's right is none. We return for this, right? Then at 4, we will get a series of 4. Right? This is what we at the 4 part we will get, and then we will get its count because at the beginning this is none, so we will set it at as the default is 0, then we will set it as 1. If is more than 2, it's not more than 2, right? So we will be track back. Why we track back is because we go to 1, goes 2, go to 4. We just run the left, right? We didn't run right. We run right. It means 2's right. We didn't run right. To the left, we already have this result to the left, and then we will go to the right. To the right, to there is no right, right? No right, we will be return what? This one, right? Then we will use 2. Left is 4. Right is what? This is the series we got for the number 2, right? And then this this one is series, this one is also a series. So both of them currently is all the 1, right? All equals 1 because it happened one time. And for the 1 part, we will be get from one's left, we already know, right? This is one's left. One's right is what? One's right is 3, right? One's right is 3. But for one's right, here it will be all right again. For if there is 3, for here is right is 3. This is if 3, right? If right is 3, for if here is 3, it will directly go to 3's left. 3's left is 2, and then 2's left is 4. Then this will be go to here, it will be same as with previous ones. Go to here is already known, so it will be add this again. Then this will change to 2, right? And then goes to 2. 2 is same as this, so it will be add another this. It will change to 2, right? This 2 will be updated to 2, and then result append none node. Actually, for this one, for this part at the beginning, I don't understand. The explanation for here is append node. Here is append nodes or the sub node. It means even which is as 2, right? Root node is 2 part. Even we just append 2, but it will be put to all of the subs in this result. It will put su's left day 4. So that's the reason why when we return this 4, it will be have this 4 to this node is a root start of the root node of this subtree. Yeah. This is a thinking and explanation and walkthrough for this question. If I hope you have a better understanding for this one. Yeah, thank you. Bye.